are getting into normal distributions a bit today. So this is norm. Focus. Norm the normal distribution. This is what we're getting into. All right. So when it comes to normal distributions, they all kind of look like a little flat ghost. Your mean goes in the middle. So X bar always goes here. And then you do your standard deviations at equal distances on each side. So standard deviation over here. 1, 2, 3. All right. So they tell us in this example that we have a normal distribution with a mean of 149 centimeters. So I'm just going to put the 149 right here. And then they also tell me my standard deviation is 8 centimeters. So what we're going to use with the 8 centimeters, okay. Can you email Boz? Oh, okay. I'll email Boz. Seven. So all you do is you add 8 each time. All right, so 157. He did also just have to go in the boys' bathroom and be like, why are we slapping each other? Can you not do this crap at home? That was the slap fight in the boys' bathroom, because apparently they're stupid. 173. All right. Hey, guys, calculate the 3 over on the left. So you need to subtract 8 each time. I know. It is difficult. All right, so what'd you guys get? 141?
133, 125.
Okay. So this is how you use a normal distribution. You place the mean in the center, add, subtract, 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 boom, you're done. All right. So I think we're only going to do these first 2 examples because that third one got split somehow. And honestly, it's not that bad. So here's a dot plot showing the weight in grams of 36 Oreos. The mean is 11.392, so that's right about here. And standard deviation is 0.081. All right. I do std.dev because otherwise kids are like, STD, and I'm like, standard, stupid, like, stop giggling. Like, literally, if they have an answer of 420 or 69 on a test, like, I hear Snickers. I'm like, me or him? Okay. Fine. Okay. All right, so here's what we're doing. All right, you're going to take the 11.38. Now, what I like to do with this is these 3 on the right side are the right part for our standard deviations. So you take 11.392, and we're going to add 0.081. All right, that says that my first standard deviation ends at 11.473. Bless you. So for 42, 44, 46. So here is that first standard deviation. Now that you've got this answer, add 0.081 to it, and that tells us that our second standard deviation ends at 11.554. So this is 1, this is 2. All right, do it one more time, and we get our third one at 11.635. Easy enough? Start back at the top again. Go back to the 11.392, and now we subtract 0.081. But we're still going to do it. Because this is where the first standard deviation ends on the large side, not where it ends on this side. Oh. kind of, but we're still going to leave it. All right, subtract it, and I get 11.311. Subtract again. You got it now? So if you think about this, this is standard deviation 1 on this side. The 2, 3 is going to be right here in the middle. Okay? Then you do it again, and I get 11.149, and that's going to be my third right back here. Okay? So I'm going to ask you to do some really hard math real quick. I need you guys to count how many little dots are between here and here. You have it on your paper too. You're counting. 26. All right, so within one standard deviation, I have 26 out of 36. What is that as a decimal? About 72. All right. So if I know there's 26 in here, how many more get added in if you go out to 2 standard deviations? It looks like 4 more here, that takes me to 30. 4 more here, that takes me to 34 out of 36. What was it? Oh, all right. And then if I go all the way out, now I've got all of my data, so that's 100%. All right. I want you guys to try the second one. You're going to be fine. I want you guys to try this one with your neighbors. Do you want like a pep song or something? Righteous Brothers? And then did anybody want to see a dog with hives? No idea. Yeah, the second one. It's got different standard deviations and stuff though. No. It's different from this one. Honestly, I can see a lot of kids trying to use info from that. But this is a puffy-faced puppy. I'd count it on this side. Yeah. After Benadryl. Yeah, I'm pretty flexible on that. Like, we're good. Just begin with Benadryl. I think for me, if I'm looking at that, 2, 4, 6. I know. I'm trying to figure out which one. I might try and split them because it's 68.5, but this is 68, and this is just the standard deviations. So I would split these 2 dots and put my standard deviation in between. So here's the reason why I'm saying kind of I might split it there, because it's 68.5. Halfway through this would be like a 69%.
Oh, you know what I did?
Oh, it's got to be a 2. I was going to say, I can't quite read my own handwriting today. Yeah, because otherwise our standard deviations aren't really standard. We have one skinny one. Okay, make sure you guys fill in the percentages on the right too. You could, but you don't have to. I'm going to try and get you guys some work time today. Stuff. That's just redundant at this point. Only this stuff. What do we think? Bless you.
Yes.
We good?
Yeah.
All right. So we'll kind of skip that third one, just because it got split between the pages and it's just easier that way. But if we flip over, today's going to be pretty short on the notes. All right. So all three of the distributions above were approximately normal in shape. Guys, listen. All right. So based on these examples, what percentage of observations do you think you'll find between 1 standard deviation, 2 standard deviations, or 3 standard deviations? So 1 standard deviation is 68, 2 standard deviations is 95, and 3 standard deviations is 99.7%. All right, so there's actually, what? Yes. So if it's a normal distribution, all right, within 1 standard deviation on either side, you will have 68% of your data. If you think about the bulk of it, yeah. So we just kind of estimated with this, but look, I've got right around 68. It happens to be 72 on this one, but I've got a large chunk of my data in here. Yeah, it's the more data points you have, it ends up working out to being 68, 95, 99.7. Because if you think about it, you do want the bulk of your data to be right around your average, right? Like, look at Norm's fat little face. I want all of, stop touching that. I want all of the data to be right here, because that is the bulk of his volume. If I go out to 2 standard deviations, literally the only things that aren't covered are his 2 little ends, right? So 2.5 over here and 2.5 over here. Once I get out to 3 standard deviations, I've probably hit darn near 100% of all my data. That's the 99.7. All right. So that is our lovely little rule. And it applies when you have an approximately normal distribution. All right, and remember, a normal distribution looks like that little single lump. Yep, unimodal. All right, Chebyshev's inequality is not something we use very often, but I figured I'd give it to you. Basically, it's asking what percentage of the observations are going to be within K standard deviations. So let's say you asked for K to be 1. Well, within one standard deviation on both sides, that should have about 68% of my data. If you wanted it to be 1.5, that's when you would use Chebyshev's. So Chebyshev's would tell you, okay, if you use 1.5 standard deviations, this is the percentage of your data points that are going to be within there. Okay? You will not need this. I'm just putting it up here. Chebyshev. It's a fun name to say. All right, so using the earlier example, what percentage of 12-year-old boys will be over 158 centimeters? So this is like the Brody one / the first one that we started with. Okay, so remember, we had X bar equaling, what, 149 on that front page? All right, and then standard deviation is 8. Okay, so if we're trying to figure out what percentage of boys will be over 158 centimeters, we can actually use that A table from yesterday and calculate it, and then we can also use the calculator. So we're going to practice it with the table, and then I'm going to show you how the calculator works. All right, so remember, I've got to find my z-score, which is 158 minus 149 over 8. And that's 1.13. It's really 1.125. But that is my z-score. What does that give me for a percentile? 90th percentile. So that says 90% of all of these boys will be shorter than 158. But what did they really ask for? Over. 100 minus 90 is 10. Okay? So about 10%. All right? Now, in the calculator, shrink this. Well, for this next one, that's where it gets a little messy. So the second one asks what percentage of boys will be between 131 and 140. So if you try to do that by hand, now you got to find two z-scores. Figure out 1.13, 1012. Oh, 87. Ah, we fixed. That's okay. So is 8708. And then what's 1 minus? So we're going to end up using one of the things under stat, and then we're going to go to test. At least I think that's where test is. No, we're looking for a normal distribution test. ANOVA, nope, calculate. Nope, here it is. All right, so I lied, it's not under stat. I know it doesn't, it's not D&E, it exists. Okay. It is under second VARs. You see where it says distribution on the top? So second VARs gets us into distributions. All right. Now, norm CVF is going to get us what we want. All right. So when it comes to norm CVF, it gives us a lower, an upper, a mean, and a standard deviation. Okay. So norm CVF. Now, if I'm looking at this one, what would be my lower bound? Yeah, 131. Upper bound would be 140. We said standard deviation was 149. Or not standard deviation, mean was 149, standard deviation is 8. Hit paste. All right. And then hit enter. So, it always goes lower bound, upper bound, mean, and then standard deviation. So for this one, I got that it's going to be at approximately 11.8%. Okay. Now, can I retry that for the one up here? So, second VARs number 2. So we said our lower bound was the 158. Now, when it comes to trying to find an upper bound, I got to put in a stupid large number, right? So you can use scientific notation. You could just hit 1 with a bunch of zeros until you feel better. Go down to paste. 13%. Does that match what we got up here? What? Oh, we read the table a little wrong. He was like, I was floating over here. I don't know. All right. So, suppose we go back to that distribution of test scores from the front page. All right. The middle 95% of scores are between 72 and 84. All right. So, that means within 2 standard deviations, I've got, so, mean, standard deviation 1, 2 and 2. So if this is 72 and this one's 84, can I work it backwards to find my mean and then what the standard deviation equals? All right, so what's the midpoint between 72 and 84? 78. So the distance from here to here is 12. Halfway through, that's 6. 6 plus this gives me 78. All right, so if this is 72 and that's 78, that makes this one here. Is that 76? No. No, it's 75. Because this is 6. 3. 3. All right, so now I know mean is 78 and standard deviation is 3. All right, keep going on the other side. That puts this at 81, 3, and 3. That's all I wanted was what's the mean and what's the standard deviation. So I always draw my picture and kind of count it back because that makes my life a lot easier that way. All right, and then the last one, can you calculate the percent of scores that are above 80%? So, can I do that norm CDF again? When it comes to a test and it's norm CDF and you do it in the calculator, type 80 and then you could go 10 to the 99th. All right, that's scientific notation for stupid large number. Because let's be honest, you don't want to sit there and go 1 and then figure out how many zeros you gave me. Just put a stupid large number. And then we needed standard deviation and mean, and we are good. This is all I would need for work on a test. Tell me what you typed into the calculator. That's it. Yeah, I said it in the wrong order. Yep. Yeah, 25. So 25.25%.